Here we're going to discuss finding the equation of a parabola, where we've been working with a parabola in geometric form, that is starting with the focus and the directrix. And remember that, and where the vertex is at the origin. And remember that when we have a parabola opening up or down, the equation is this. It's x. Well, let's start it off with the squared. So it's going to be, x squared equals 4py. So that's for a parabola opening up or down, and the focus has coordinates 0, p. So p can be either positive or negative. So this is up for a parabola opening up or down. Okay, and then if a parabola opens left or right, the equation is y squared equals 4px. So it's 4px. Notice that that's not a function, and the focus for this parabola is going to be p comma 0. And so that parabola opens left or right. So what we're doing in this video is we're trying to find one of these equations given some information. So let's see an example. So find an equation for the parabola that has its vertex at the origin. Okay, so the parabola goes through the origin and has focus negative 1/3, 0. So the focus is right here at negative 1/3. Now remember that a parabola always opens towards its focus. So this parabola is going to open like this. It's going to open to the left. So the parabola is going to look like this. So if we just sort of draw it in just to get an idea of what we're talking about, the parabola is going to open like that. So the equation is going to be of this form. It's going to be y squared is equal to 4px. And remember that because this is the focus has coordinates p comma 0. So this number is our p. So our equation is this. Y squared is equal to 4 times negative 1/3 times x. So our equation is y squared equals negative 4/3 x. And that's our answer. So these problems aren't especially hard, but you have to kind of orient yourself. And a nice thing to do, I find, is to actually plot where the focus or the directrix is, and then get an idea of what the form of your equation has to be, and then contextualize the information that you're given. All right, let's try another example like that. So let's find an equation for the parabola that has its vertex at the origin once again, and with directrix y equals negative 2. Okay, so the directrix goes through negative 2 on the y-axis, right? So here's the directrix. So now remember, so this is negative 2. Remember that the directrix and the focus are on opposite sides of the vertex. So the focus, if this is negative 2, the focus must be at positive 2. So the parabola must open up like this, and it opens towards the focus. Okay, so this is an upward opening parabola. So its equation is going to be x squared equals 4py. And is p positive or negative? Well, the coordinates of the focus are, in this case, 0, p. And I can see that the p is positive. So 0p. And in this case, in particular, we have 0, 2, right? Because the parabola opens up. The focus has a positive y coordinate. So p is 2, so our equation is x squared is equal to 4 times 2 times y, that is x squared equals 8y. Okay, and so all the problems in this section are of variations like this, where you're given some information about either the directrix or the focus. And also recall that in some problems you're going to have something called the focal diameter. So if you're given information about the focal diameter, all you have to do is remember that by definition is the absolute value of 4p. So if they give you the focal diameter, that's telling you something about p, which connects to the focus. Okay, in the next video we're going to talk about ellipses, and we're going to we're going to present the equation for ellipses from a geometric perspective as well. All right, until next time.